the form of what does it mean for something to be a rational function? So in your parent functions list, which ones are rational? Share, please. So if you get out the sheet of all the functions on it, which ones were rational? Ones that have a x in the denominator. You don't need to get it out. Which ones had an x in the denominator?
1 over x and the reciprocal.
Okay, the reciprocal. So the reciprocal is a rational function.
The 1 over x squared.
The 1 over x squared, the volcano. So those were the parent functions you had for rational. So anytime you have a rational function, it usually means you got x's in the denominator. Okay? It's a fraction with x's in the numerator and the denominator, or just the denominator. And so here's a generic version of a rational function. It kind of looks like a polynomial over a polynomial, right? I got my highest power, 1 power less. I have a different power probably in the denominator, and then 1 less, and so on. So it's just going to basically look like some sort of a polynomial over a polynomial. So underneath that, I've got instructions for vertical asymptotes. And then underneath that, we've got what? Instructions for vertical asymptotes, instructions for horizontal or oblique asymptotes, and then down at the bottom I have steps on how to graph a rational function. So this is just a generic reference sheet, how to find verticals, how to find horizontals. What's the word oblique mean?
Diagonal.
That's a diagonal asymptote, okay? Because occasionally you will have a diagonal asymptote. And this, Hawks really does not make you graph them much. Their idea of graphing is just asking you for the asymptotes and then naming 4 points, all right? So moving on to the next page. Okay, so on this page, I'm giving you some rational functions, and I'm asking you to find the vertical asymptotes. So look back at the previous page, and what were the rules for finding vertical asymptotes? Factor and cancel if possible. Okay, so is there anything you can factor here on example 1?
No.
Okay, so what does it say to do after you try to factor and cancel?
Set denominator equal to 0 and solve.
Set the denominator equal to 0 and solve. So if I set this equal to 0 and solve, basically I'm saying, what will make my denominator come out to be 0? 2. So that means I have a vertical asymptote at 2, right? So I have a VA. I have a vertical asymptote at x equals 2, because that's what makes my denominator come out to be 0. Now that makes sense with what we already know. This is a reciprocal function that's been shifted how? 2 to the right. So if I take the reciprocal and I shift it 2 to the right, sure enough, my vertical asymptote is at 2, right? That makes sense with what I already know. Now, when you get to problem number 2, this is one you're probably not going to be able to look at this one and go, oh, wow, I know what the graph of that one looks like. This one you could, because it was just the parent function shifted 2 right. But that's okay. I can still find the vertical asymptotes. What was the first step to finding vertical asymptotes? Factor. Has this one got anything I can factor? Yeah, the numerator will factor. What does it factor down to? That's difference of squares. X plus 3 times x minus 3. Does that make sense? Difference of squares always factor to conjugates. I have an x plus 3 on the bottom. Well, what does that mean?
You can cancel.
Okay, what can I cancel?
The x plus 3 and x plus 3.
All right, so when I cancel the x plus 3s, they're gone, and now I have what?
X minus 3.
X minus 3. Okay, well, let's see. If I go back and replace, if I put this f of x in front of that x minus 3, I would have something like this. F of x, which means the same thing as y. Well, what do one of those functions look like?
The line.
Oh, that's a linear function, right? So I had this crazy looking rational function to begin with that we thought might look really crazy, but when it all comes down to it and I factor and cancel, all I've got is a line. But I have one little problem. Initially with this thing, I have this denominator, and if I let x be negative 3, what happens to my initial denominator? That would equal 0, and that's not allowed, right? I can't ever get 0 in the bottom of a fraction. So what does this mean? Anybody remember from Algebra 2?
0 whole.
There's a hole in the graph, right? It doesn't mean I have an asymptote. I have a hole in the graph. So this thing is really just the line that I'm used to seeing. How do I graph that line?
The intercept is negative.
Intercept is -3, all right. Y-intercept's -3. What else? Up 1 over 1. So if I go up 1 over 1 continually, it's going to look like this, right? So that's what that line looks like, but I'm supposed to have a hole at which one? 3 or -3? Okay, at -3. So at -3, that would be this point down here, right? That one would be at -1. That one would be at -2. That one's at -3. So I have a hole. So right there, there's a hole in my graph. So does this thing have any vertical asymptotes? No, it has none. So on Hawks, they're going to state the vertical asymptotes, but you'll have an option of putting none. So there are no vertical asymptotes.
Okay, wait. Can you show me how you the hole again?
Yep. So are you okay with the algebraic side of it?
Yeah.
Okay, so when I get this, I notice that it's a line. Okay, so I graph that line. And so the graph of this function right here would not have a hole in it. But I'm trying to graph this function. And this function looks exactly like this function, except for it has a hole at the -3, because -3 is what makes my denominator turn out to be a 0. So my function has to be undefined at that value. I can't plug in -3 into this function, because then I get 0 in the bottom of my fraction. So for example, let's say you plug in the number 0. If you were going to go to this original function right here and plug the number 0 into it, what would you get? -9 over 3, which is what? I get -3 over 1, which is -3. Is that point on my graph over here? Sure enough, it is. Okay, well, what if you want to plug in a -3? You plug in a bunch of points, but then you get to -3. You go to plug it in, and what do you get? You get -3 squared, which is 9. 9 minus 9 is 0. You get, and that's really not a problem, but this is. You plug it into the denominator, and you get 0. You can't have 0 on the bottom of a fraction, right? Remember, no, you can never have a 0 on the bottom of a fraction. Okay, so that's what happens. So what do we do in mathematics when we get a 0 on the bottom of a fraction?
You can't include it.
You can't, but what do we call that? It doesn't get a number. It gets undefined, right? So in other words, when I plug a -3 in, I get out an undefined. How do I represent an undefined on the graph? Either an asymptote or a hole in the graph. Now that doesn't happen if I plug it into this function. Okay, this function would not have the hole in it, but this one would. That's the only two differences between these two things.
I don't understand like the graph part of it.
Okay, so I got way too much stuff on here. So let me go to a plain piece of paper. And let's graph this function. And let's graph this function. Okay, when you go to graph this one, it's just a line that crosses at -3 and has a slope of 1. Like that, right? So we remember the relationship between this equation and this line. In order for them to match, every time I plug a number in for x and work this out, I get a number out for y, and that makes a point, right? All of those points have to be on this line. Okay, so when I go over to graph this one, if you were to graph it on your grapher, it's going to look exactly like the last one, except for one little thing. When I'm at -3, I get an undefined value.
So anywhere on -3, like vertically,
Yeah, there's nothing.
it's always going to be a hole.
There's going to be a hole there.
Okay.
Because anytime I plug a -3 in, my denominator comes out to be 0, right?
Okay.
Now, if I didn't have something up here that canceled with this, it would be an asymptote, okay? If I had this. Let's say I had y equals, I don't know, x over x plus 3. That's a completely different story because I don't have anything to cancel. Only when it cancels is that a whole. So this one would have a vertical asymptote at -3. Okay? But this one doesn't because the x plus 3 cancels out of the problem when I factor. Okay? Now, I will tell you, I'm a little disappointed in Hawks on this lesson. They never give you, they might give you a problem with a whole, but they never ask you to state the wholes. They will only ask you for vertical asymptotes and horizontal asymptotes. Okay? Maybe something will factor and you'll have to throw that out, but it'll never ask you to state the whole. It'll only ask you to state the vertical and horizontal asymptotes. And this one had no vertical asymptotes. Does that make sense now?
Yeah.
Somewhat?
So it has no vertical asymptotes because it canceled?
Because the x plus 3 cancels out of the problem. Okay, when something cancels out, it means you have a whole and not an asymptote. Okay, everybody okay with that? Okay. All right, next is example 3. Okay, so example 3, same thing, I'm asked to find the vertical and horizontal asymptotes. What's it say to do first? Factor and see if anything cancels. Will this thing factor? I can do some factoring on it. The numerator I could factor out of what? A 2, which would leave me with an x squared plus 2. And then there's nothing I can do with that, right? If it were x squared minus something, I could consider difference of squares, but I have a plus sign there. What about my denominator? Anybody remember factoring one of these?
X minus 3
Okay, times what?
times x minus 3 times x minus
Nope.
X plus 3.
Nope. Remember, are these both nice cube roots?
Oh, yeah.
Okay, I have subtraction, so we call that difference of cubes. So back earlier in the year, we learned a formula for sum and difference of cubes, and nobody ever remembers them. You're not, because you just don't use them a lot, but that's why they throw them back in here to refresh your memory. But if you think of sum and difference of cubes, the formula looks like this. A minus B times A squared. Remember the SOAP thing? This sign is the same as this one. In other words, that's same. O means opposite, so this sign's the opposite. Then I have A times B, and the last sign is AP, which stood for always positive, B squared. Okay, so that's how you factor the sum, or I'm sorry, the difference of cubes.
Wait, wouldn't that be a squared plus ab then?
Nope, because this is the, oh, yep, you're right. That should be the opposite. Thank you. I don't know what I was thinking there. This sign is the same as this one. This one's the opposite of that one. And this one's always positive. Okay, so A is the cube root of this. So what's the cube root of x squared? Okay, what's the cube root of 27?
3.
So x minus 3. That's my A minus B. My A is an x and my B is a 3. All right, so what's A squared? X squared. I simply take A times A. What was my B value?
3.
A 3. My B value is a 3. So I need to take A times B. So x times 3 is 3x. Always positive. And now I need to take B and square it.
9.
So that's a 9. And if you remember from earlier in the year, I told you that these will never factor. So don't even try to find something that will multiply to give you 9 and add to give you 3. You'll never find anything. Anytime you use sum and difference of cubes, this never factors. Okay? Okay, so does anything cancel?
No. Yep.
No. All right. So vertical asymptote will happen anywhere my denominator turns out to be a 0. What makes this turn out to be a 0?
3.
3. So I have a vertical asymptote. Because there's a plus sign right after both of them. Okay? You only get to cancel things that are multiplied. So if I had a parentheses down here that said x squared plus 2, I could cancel the whole parentheses because the whole parentheses is times something. Okay? But I can't do that with addition. So I have a vertical asymptote at x equals 3 because 3 makes this come out to be 0, and 0 times anything is 0, right? Okay, now is there anything that will make this thing turn out to be a 0? What do you think? Is there any way I can make an x squared plus a 3x plus a 9 equals 0? Well, I know I can't solve that by factoring. How do you solve quadratics when you can't factor them? Quadratic formula, but do you remember I told you earlier in the year that anytime you use the quadratic formula on one of these, where you had to use sum and difference of cubes, you always get imaginaries, okay? So I don't have imaginary vertical asymptotes, right? So I don't have to worry about this one. This one right here is going to tell me my vertical asymptote and only that. Never, ever worry about trying to do the quadratic formula, because every time you're going to, if you do it, you won't get a wrong answer. You're just going to get something imaginary, and you can't have imaginary vertical asymptotes. Okay?
Is that, so you only have to worry about if it's a cube, not a square, so if it's squared?
Correct. If it's a square, you're going to do different, like if it's x squared minus 16, you're going to do x minus 4 and x plus 4. Okay? It's only sum and difference of cubes where that happens. Okay? Never going to produce a vertical asymptote. Okay, one of these is never going to produce a vertical asymptote. Because I did sum or difference of cubes. Everybody okay with example 3? All right, example 4. What's the first step to finding a vertical asymptote? Factor if possible. Is that factor?
Yes.
Okay, your denominator will factor. Anything multiply to give us 5 but add to give us 6?
5 and 1.
5 and 1. So now we have that. 5 and 1. Anything cancel?
No.
Why can't I cancel the 5s?
That's not what I gotta actually.
5 has a plus sign in front of it, right? Okay, 5 does not have a multiplication sign beside it. Okay, so nothing cancels, so I don't have to worry about any holes. So what's the next step?
Find what it makes the denominator.
What makes your denominator come out to be a 0? What will make my denominator come out to be a 0? Okay, x equals -5 will make my denominator 0. X equals -1 will make my denominator 0. So that means those are both what? So I have 2 vertical asymptotes. And every time you state a vertical asymptote, you must say x equals in front of them, because a vertical asymptote is a vertical line, and that's how you name vertical lines. So you would say x equals -5, comma, x equals -1. And you'll probably say to separate your answers by commas. Everybody okay with example 4? Okay, example 5. What's the first step in finding a vertical asymptote? Factor if possible. Can we factor that thing?
I'm sure.
Sure hope so.
It's pretty big.
It's pretty nasty looking right now. So the denominator is probably the easy part to factor. How does your denominator factor?
You can pull out a 4.
Pull out a 4, which will leave me with 2x plus 1. Does that make sense?
Yes.
Okay, numerator. What do you suggest for factoring the numerator?
You can pull out a 4.
I'd pull out a negative sign and a 4 probably, okay? If I pull out a negative sign and a 4, that's going to be what, 6x squared?
Yeah.
Plus 7x plus 2? All right, now do you think that factors? How would I tell if the numerator factors?
That's 6 times 2.
Do the little rainbow thing there, multiply those together, and I get a 12. And then I ask myself, is there anything that multiplies to give me 12 but adds to give me 7?
Yeah.
Okay, so that means I could use a box on this thing, right? So now we can proceed to the box, now that we know that's going to actually factor. So that's a 6x squared here and a 2 here. I know now what goes in these 2 boxes will be whatever multiplies to give me 12, but adds to give me 7. What will multiply to give me 12 and add to give me 7? You said 3x, and 4x. Everything's positive, so that's nice. Let's see, so that would give me a 3x here, 2x here, 1, 2. Okay, so my denominator is still a 4 and a 2x plus 1. My numerator has a negative 4, a 2x plus 1, and a 3x plus 2. Okay, so what can you tell me about this rational function now?
You can cancel out the 2x plus
Yeah, so I've got a whole somewhere,
and the 4, but you have to leave the negative.
which the 4 cancels, but it doesn't tell you anything about a whole or anything like that because it's just a constant, right?
Well, you have to leave the negative.
Yeah, we have to leave the negative, you're right, but the 4s will cancel, but that doesn't mean I have a whole at 4. Okay? I do have a whole at what? What makes this thing come out to be 0?
Half, negative half.
At negative half. So I have a whole at negative half. Do I have any vertical asymptotes at all? I have nothing left in my denominator, right?
Yeah.
So there's nothing left to equal 0 in my denominator, so I have no vertical asymptotes. Does that make sense? Is everybody okay with example 5? Okay, example 6. What's the first step? Anyone at a time? I'm looking for a vertical asymptote.
Factor.
Try to factor. Anything factor on this thing? Okay, I've got difference of squares in my denominator, right?
So x minus 4 and x plus.
X minus 4 and x plus 4.
Oh, and look at that.
And look at that, what happens?
You can cancel.
Okay, the x minus 4's cancel. So that tells me I have what?
1 over x plus 4.
True, that's what I'm left
Oh,
with.
you have a whole.
Okay, I'll be left with this, but I do have a whole where?
At 4.
I have a whole at x equals 4. Okay,
And then you have a vertical.
and then this is left over. So now I have a vertical asymptote at x equal negative 4. The vertical asymptote's at negative 4. The whole is at positive 4. Okay, so I have a vertical asymptote at x equals negative 4. Now this is the only one they're going to ask you about. They're not going to ask you to provide a whole. Yes, Alexis.
How does that work?
Okay, so this is the one that canceled, right?
Okay.
What makes it 0?
Oh, okay, so that, okay.
It's all about what makes it come out to be 0.
Gotcha.
So the one that canceled, what makes it come out to be 0 is a positive 4, so that's why there's a hole at 4.
Okay.
Okay, what makes this one 0?
Negative.
Negative 4. That's why you have a vertical asymptote at negative 4, because that makes this come out 0. Okay? Everybody okay with that? Example 6. So is that our last example on vertical asymptotes?
Yes.
I believe it is. Okay. Okay, so now we're ready to talk about horizontal asymptotes. And I kind of have a chart for you there. But before you do the chart, why don't you go back to, well, it's all right. Let's stay on this one, okay? I have a bunch, basically everything that's on this chart I have on a sheet, and I'm going to pass those out, and you're going to decide where the asymptote is at. Okay, so let's take note to all of the powers in this chart right here. Compare the power of the numerator to the power of the denominator. What do these all have in common? Same. The power's 1 and 1. The power's 1 and 1. The power's 1 and 1. 1 and 1. 4 and 4. And as you go clear down this aisle, everything, the highest power of the numerator matches the highest power of the denominator. Anytime that happens, you have a horizontal asymptote at y equals a over b. Does anybody know what a and b are? It's on that reference sheet that I handed out to you, the very
Oh, is
front
it the
page.
Coefficient of the highest
It's the
power?
coefficient of the highest power of your leading term for your numerator and your denominator. So this is a, and b is a 1. Okay, so what's my horizontal asymptote on this one? Y equals negative 3 over 1, which is just y equals negative 3, right? That's my horizontal asymptote on this one. What's my horizontal asymptote on this one?
Negative 2 over 1.
Y equals negative 2 over 1. What's my horizontal asymptote on this one? Negative 1 over 1, which reduces to just negative 1, right? What's my horizontal asymptote on this one? Negative 2/3. What's my horizontal asymptote on this one? Positive 1/2, because you have negative 1 over negative 2, so y equals 1/2. So anytime your highest powers are the same, that's your horizontal asymptote. Does that make sense? Okay, so when you look in the middle column, every rational function in this column has a power in the numerator that's less than the power of the denominator. 4 to 5, 2 to 3, 2 to 3, 2 to 3. This one has a power of x to the 0, right? So once again, the power in the numerator is less than the power in the denominator. Every single rational function in this column has that property. Do you agree? So anytime that happens, what does this give you? 0. So I have it on all of these all have the exact same horizontal asymptote. Okay? Y equals 0. Y equals 0. All the way down. Every one of these rational functions has a horizontal asymptote on top of the x-axis. Because y equals 0 would be a horizontal line. It would land right on top of the x-axis. Okay? All the way down there, every single one of them. So when does that happen? Power of the numerator is less than the power of the denominator. Okay? Everybody okay with that? Okay. And in the last one, anytime the power in the numerator is 1 more than the power in the denominator, we have what's called an oblique asymptote. Okay? So when the power in the numerator is more than the power of the denominator by 1, we have what's called an oblique. And what does it say to do to find an oblique asymptote? Use long division. Yikes, that's yucky. Yep, that's right, it's yucky. You got to use, but I will tell you this, anytime you do one of these, this only works when this power is one number bigger than this one. And when you do that and you use long division, you end up with something in the form of y equals mx plus b. Okay? And you always ignore the remainder. Okay? So we'll practice finding some oblique asymptotes here in a minute. But for right now, I want you to go back to your reference page. Go back to your reference page, and let's go through those rules again, because you're going to forget this by the time you go to your homework, which means you can go back and watch the video again, or you can go to your reference sheet and look at it. So my reference sheet is right here. What are the rules for horizontal and oblique asymptotes? It says if n is less than m. What does that mean? Yeah, so here's n and here's m. They represent what? All right, so m and n are the highest powers in your numerator and your denominator. So when you come here and it's comparing n to m, it's important you understand what that is, right? That's the powers of my denominator. So if n is less than m, then where is my horizontal asymptote at? 0. You have one at y equals 0. That's like that entire middle column, right? That entire middle column has an asymptote of y equals 0. All right? What if n is equal to m?
Then there is a over c.
Okay, then you have one at a over c. That was the coefficients, right? So that's like the first column. Because what are a and c? Look up at the top there. What are a and c?
I see.
They're the coefficients. Does that make sense? I want you to be able to read this doc, to be able to go back and read it and understand it. So I'm trying to make sure you understand what the letters stand for.
This chart thing.
Yeah, I know. It says A over B, doesn't it? You might want to change that to A over C. Okay? A over C. Okay, so if they're equal, you have the coefficients. If the top is less than the bottom, you have y equals 0. And then if n is m plus 1 more, That's the third column. That's where you have an oblique asymptote, okay? And we use long division for that. And then any other case scenario, you just have no asymptotes at all. You might have vertical, but you won't have horizontal or oblique, okay? All right, so let's go back and let's do a long division one. Yes?
So on your front it says y equals 0, n is bigger than m, or smaller than m.
Uh-huh.
But on the chart it says that m is smaller than n.
Okay, let me go look at it. Maybe my chart needs adjusted. So it should be n is less than m. The top is smaller than the bottom. So here it just says y equals 0. Are you looking up here?
Yeah.
Oh, right here, I see. If
On ours it's m is less
Oh, what?
Because I was looking
Oh,
at
okay, so maybe I made an adjustment, but I must have copied off the old one for you guys and didn't print the new one. Does yours look like mine?
I have no. I have n is less than n.
Okay, change it to look like this, because it looks like I've adjusted it here but didn't adjust it there. Okay, so has everybody got these correct now?
Yes.
Okay, and you might want to change this B to a C, right, to match the front page. The front page calls this C, so make that a C and make sure yours match these up here. Okay? Okay. All right, so we want to do an oblique asymptote. So if you take this one, we are going to do long division with that one. So I will go to a blank piece there. So you can do that on the back of this if you want, or wherever you have, maybe at the bottom you would have space. Okay? So an oblique asymptote. What is my rational function again for that first problem in the third column? What's the first function in the third column?
Negative 2x cubed plus 4 divided by x squared minus 1.
Okay, so we have that, right?
Yes.
So we're going to do long division. So long division is x squared plus 0x minus 1. And then in the inside, I would have negative 2x cubed, a 0x squared, a 0x, and a plus 4. So we get to review our long division just a little bit. So what times x squared will give me this? What times x squared will give me this?
Negative 2x
Negative 2x. What do I do with a negative 2x?
times by x squared.
Take it times all three of these and put it underneath these three, right? So if I do that, I'm going to have a negative 2x cubed, a 0x squared, and a positive 2x. Okay, what's the next step? Change your signs. So if I change my signs now, these go away, right? These go away, and I'm left with what? Negative 2x, bring down the plus 4. So, is there anything that when multiplied by x squared will give me this?
No.
So I would just put a plus what? Plus 0, and that's my remainder, and you get to ignore the remainders in this problem. Ignore remainders. Okay, so remember me telling you your answer should come out looking like y equals mx plus b? Okay, well there's your mx plus b right there. Okay? Y is equal to negative 2x plus 0. You do not need to type in the plus 0. You just type in the y equals negative 2x. I just wanted you to understand there that it matched the y equals mx plus b. Okay? All right, so in your chart where it says oblique asymptote, right, y equals negative 2x. Does that make sense? In your chart on the third column, first problem, right, y equals negative 2x, that is your oblique asymptote. In the chart on the third column, top problem, y equals negative 2x. Okay, well, what does this look like? It's a diagonal line. Yeah, it's a diagonal line. So you got it going through 0, and the slope is down 2 and over 1. So your oblique asymptote, your graph is going to somehow follow this line. So your graph might look something like this. Okay? Yeah, they're kind of weird. But they follow a diagonal. They usually have a vertical asymptote they follow as well. Okay? Looks like I have a vertical asymptote at 1 and maybe -1 also. Okay? Which I didn't draw those in there. But typically when you have an oblique asymptote, it does something like that. Okay? And you could graph it in your grapher there to see, just to see what's happening on that one.